Hello, folks. I want to do a video to kind of go alongside the one about sprites. Now, I just completely redid my computer from scratch here. So I added some new drives, replaced my system drive, and upgraded to Windows 11. So I can't guarantee everything's going to work exactly like I know because everything's moved around and refreshed here, but we'll try our best. I'm going to go ahead and bring out our Unity window here. So I did also just install a new version of Unity 6. But because I have some projects that are using the older versions, I downloaded them too. If you look at my projects, you can see that they use different versions. Some of them I updated, some of them I did not. When you see these versions, LTS means long-term stability or something like to that effect. So for installs, or long-term support, that's what it is. LTS means long-term support. That tends to mean they're a little bit more stable, but you tend to have things that are sort of like beta or test. This is the new, I think, Big Dog on the Street, the kind of newest version you do with all the bells and whistles. So we might be popping back and forth between these. You can install other editors or locate an editor that got orphaned. Like in my case, since I had two drives that did not completely wipe, they are still kind of in the same spot, so I had to reattach them to new downloads. For instance, Creative Cloud. When Adobe app runs all the others, that Adobe app itself was a fresh install in the new version of Windows. However, all the orphaned files that were still on a different hard drive, I had to reattach those. Okay, so we could make a new project. Some of you might already have one started. Let's probably do career game. If I wanted to do a new one, I'll go ahead and try this new version. I'll do a 2D platformer micro game, but you'll notice there's some pre-mades. Download the template. We'll give that a second. Okay. Oops, I could have named it there, which I should have done. You can always go back and rename it, though, if you want. You can show it in the File Explorer, do command line arguments if you know that stuff, remove it, etc. Now, I am connected to Unity Cloud. And so I have a license in an organization, which is my school account. And I think all of you will be set up in the organization, or at least most of you. There's, of course, downloads here, community, learn, etc. So this hub runs all the actual Unity versions. Okay, so let's go ahead and open this up. It says it's already open, so I just need to click on that. It's most likely in my other window. Okay. Let's try this one here. Hopefully the recording is still going and the audio will come through all right. I'm going to stop this while that loads so I can just check and make sure the audio is working. Okay. So this should be loading up now. Okay. So now we're just going to let it load up here. And since this is that brand new version 6.0 instead of the 2021, 22, 23 versions, it'll be a little bit new to me too, but I'm guessing things should work about the same. This has a little bit more in it that I really want at this point. I'm going to close those tutorials. Let's go ahead and close this one. So if you do need to close a project, you can do it just by closing the project here. Just going to do universal 2D. Preferably, in this case, I want an empty project. Now, they do have a new system. So for sprite stuff, we typically tend to do it with animations and sprite sheets. However, they have a new bone system that's sort of interesting. So in a later video, I'll most likely talk about that as well, so we can compare and contrast them and see which one works best for what we need. Oh, this takes a long time to open. Okay, while that's going on, we can see the settings here, our projects. So that's my default installation. If you needed to move it to a different drive, something like that, you could. My main installs for the editor and downloads. Appearance. Language. Licenses. What if I could add? I would have to get the license number from our school one. We'll worry about that later. You can opt out for analytics. And then you can do beta or production versions if you want to test new features. If you were to install one, you would get an option like this. Pre-releases, archived versions. You could go back to older ones. Let's see, that's a pre-release for Unity 6.1. Let's see all my installed ones. You can go to test out the beta releases there. I think most of you would try the learning things. You can go into features here, and that will take you to the site, but you can do things right in Unity here. So 2D roguelike, create with code, etc. Unity Hub, and I recommend you check this out too. 2D beginner, and then all sorts of resources. So they have a new AI component, Unity Muse. There's the asset store. If you haven't checked this out, you should. Quixel Mega Scans is used for making really realistic rocks and things like that. And I believe recently it just went to an included version on here. It used to be free, and I think now it is something that perhaps you can pay for. You can see the particles and shaders, tools, play modeling, localization, behavior AI, things like that. Essentials, Web3, generative AI, audio and music, machine learning services, etc. So all sorts of options in here. You can buy like characters and props and things like that. Here are some free characters you can do for, say, 2D sprites. There's GUI stuff, graphical user interface, textures and materials. Things like fancy bundles, textures, space shooter pack. All sorts of cool stuff in here. Pixel effect lightning, camera rigs. Okay, so here we go. We got a fresh scene. So I'm going to go ahead and see if I can bring up my physical stuff. I just remember my local saves are on my computer. I might not have them here. Let's see if I can get them in my drive. Can't remember if I put them in there. We'll check real quick. Oh, that's right. Let's go ahead and set a size in Piscal here. I'll just make something simple. Actually, in this case, because I have the Mr. Schaff animation we made in the other video. But you know what? Let's go ahead and try getting something from the indie store here. So you can import them directly in Package Manager. I'm going to tell this to always let it open Unity Editor from the browser. These have a few warnings here. This is deprecated, meaning it's going to lose support, which is why it's no longer supported. But looks like this all came through all right. Okay. So I'm going to go ahead and maybe tuck this away. It won't let me minimize it, but I could try and put it up here. Notice you can move these tabs around and recombine things. Okay. Let's see if we have any new stuff in our assets. So assets down here has some of the things we'll be using in these. There's a whole lot of stuff in here. Okay, so I'm trying to bring this into the project here. Okay, now it's in assets. So I can see these spreadsheets, for instance. So this is fall, jump, etc. And we created these manually. And the way you do that is you take something like this and you go to Inspector, Multiple, and you try and set this up to fit and then hit Open Sprite Editor. Oh, I don't think this has, oops. I don't think that one has actual multiple things in it. Fall, idle, jump, run. Let's try run. Okay. So multiple, Open Sprite Editor. It's got each of these. If we knew the exact size, we could set it here by cell size, 64 by 64. Each of these is 64. This is why I told you keep your cell sizes the same. Even if in certain, let's say you crouch into a ball, so you start standing tall and you have a larger vertical frame, and then when you crouch in the middle, or think about the morph ball in something like Samus game or Metroid, right? It takes up less of an area than Samus when they're standing tall. However, you want the total height and width to stay the same because it's going to use that size to figure out like where the center is or where the character is. And if the sprite overall size is changing in the midst of it, it's going to lose track of, like, the character will shift around the screen. And I'm not talking about a normal movement like you want. I'm talking about like they will suddenly offset left or right, because the overall size that it uses to figure out their placement on the screen has changed. So you want these to stay universal. We could also do it by cell count. So we did the columns and rows from Piskel. It'll tell you when you export the sprite sheet exactly what the rows and columns are. But in this case, this is going to work fine. So I'll do automatic, slice, apply. Okay. And then we'll select all of these. So I'll click that one, we'll shift to click this one. We'll drag them out here. Let's make an animation. We'll name that run. And notice where this is going. My project, ask this pixel adventure 1, etc. So if that's not correct, change it up here. We can move it later, but you don't want to move things after the fact because they're tracked in Unity as you create them. So if you move it outside in the file system and not Unity, it can cause problems. Unity might not know where to find it. So I'll hit save. Okay, now we have this animation here. And if you want to bring out a bit more stuff for the animation here, you're going to go to Window, and this has all your panels in it. You can also bring out animation. So notice where I move this is going to kind of set it to a certain spot. Okay. Just quick note up here too, as far as selecting these, you can go to one column layout if that's easier. That way you can select them like this. Sometimes that can be a little easier for selecting the multiples. Okay, now if we have something like this, we can use it with the sprites. Now let's talk about programming in here as well. So we know that we're going to need a script that can program our character for movement and things like that, right? So one thing I want to do is I want to go to Edit, Project Settings. You can use an input manager here, map some things. I'll be making a new one of those at some point. Just looking through everything here, making sure we don't miss anything. There should be something for input where you can choose whether to use the old or new system. Okay, so here, player configuration. There was an old input manager and an input system package new. And so depending on both what you're looking to achieve and tutorials, it gets confusing because some tutorials use the old one. Some systems and tutorials use new ones. So if we turn on both here for player configuration, active input handling, you could put active input handling up there. That's what I was trying to find. Change that to both, just in case. I'm going to make sure I save. Okay, so now let's go back to our overall assets. And I want to make sure there is a folder for scripts. So I will go to create folder. We could separate it like player scripts, etc., but I'm just going to do scripts, enter. Let's double click scripts, right click, create. We're going to make a script. Now, there used to be a mono editor that was used along with it, so it came with it for free. Now most people use VS Code, which is the same thing we use for our programming classes. So C# is the language we use. So we have some options here. Let's try this. And we'll name it player controls. Enter. Okay, now it shows it to me here. Let's go ahead and double click this. It's going to do something here. Now you might get something like this. Do you trust the authors of this folder? For this type of thing, if you know it's legit, you can go ahead and hit that. And yes, I trust the authors. I do want to install any recommended Unity extensions. It's going to have me get some external stuff, this SDK. Now I'm going to tell it that any of the stuff it needs is trusted domains. It's basically just grabbing some extra stuff from Microsoft. So now we probably can't do some of the stuff at school without the administrator password. Basically, I'm going to tell it to go ahead and open this when it can. Notice that's an admin install too. Now on my other screen here, I'm getting a user account control thing. I have administrator, of course, on my home computer. Okay. So it's going to have us restart VS Code after we get this extra stuff. You probably heard of .NET. Maybe heard it mentioned software development kit is what that means. All this stuff. If you've heard Jupyter notebooks are a way to run code line by line to see how it works. It's kind of a cool feature. So Polyglot Notebooks is part of that. Apparently it's required extension. And then what we're doing here, this is VS Code. We use it for all our Python and other coding. So it's getting this extension to make Unity work well with this VS Code coding environment. We'll talk more about VS Code itself, but you'll see that we could set things like auto update and stuff for this. Copy settings. VS Code is its whole own barrel of worms here, so I'm not going to go too deep into that right now. I'm not actually sure if that ran. Well, I think it did okay. I'm going to have to restart this. Well, that's good. We'll take a look here. So as soon as .NET is downloaded, hopefully that will take care of this message here. So VS Code is really fully featured. It's my main coding thing. You can do files. You can do a text file is a text file, but you can do Python files, C# files, JavaScript files, HTML files. That's just programming. You can open a whole folder full of files or a particular file. You can make workspaces in here. So you might want one workspace for like HTML web stuff, one for JavaScript, one for Python. That's how I separate things. Workspaces have different components, extensions based on language you're using. You can open recent, add folders to workspace. You can save each workspace as you like it, like for different languages. Save as. You can share, auto save. I'd advise you turn this on. Settings, stuff like that. revert to a previous version, close the editor folder window, exit. Here you have things like undo and edit, that is, undo, redo, cut, copy, paste, find, replace. Replace is cool because you can find like where one word, let's say you made a whole bunch of tags, you need to change all of them. You can change them all at once by doing replace, and you can choose the word you want replaced and what you want to replace it. And you can just replace that one, or you can hit replace all, and we'll replace every instance of that in the whole document. We can do a line comment, which is a human readable thing not interpreted by this, so that you can leave notes in the code for yourself or other people. The interpreter here doesn't look at them. The computer doesn't read them. They're just for us. We can do selections, move lines down, copy lines, add cursors above, etc. The command palette is something we use up here to type in a bunch of commands. Usually you don't actually go around here clicking a whole bunch of buttons. A lot of stuff is done right from the command palette with shortcut keys or things you type in. So Control-Shift-A, that's something you might want to memorize. We can change the appearance, all the panel positions and stuff. We can change the editor layout. Like if we had two files, we could split them so they're in two vertical panes. Source control is stuff like GitHub or version control, where different people or different devices can send everything to the same location so that it's unified across all computers and all systems. You can run like a problems output, etc. We'll talk more about that stuff later. Okay, I think .NET is set. Let's see if maybe I can get that to run again. So I'm going to go ahead and close this. Just restart it, double click the script. Let's see what happens. All right, so it's going to show us our script here. Now we did download the SDK. I'm going to hit Control Alt. Let's see. Control Shift A for this. Depending on what you're doing, like I said, this is a powerful thing where you can access like sort of all the commands and things that you need. So I type in dot and see if I can figure out why it's not accepting that thing we downloaded. So it's telling me I need that .NET SDK. I'm going to try this. Install system-wide. I think that's the version I downloaded. Okay, it's telling me it collects usage data. So this was still saying there's no SDK. Let's save this. I'm going to try opening it one more time since we just did that install. Getting the stuff set up is one of the hardest parts. It's super annoying. There's always a bunch of dependencies and stuff that you need. One other thing that sometimes works with this is got a Microsoft Store to download these things. Sometimes they work better than just straight up downloading them from the internet. So let's try that. Let's see if we can get .NET. Yep. Okay. So it's acting like we just need to install it, which I feel like I did. Let's try this one more time. So this is an install tool, I guess I just added. Well, let's try this. Control A, remember that's what opens that menu at the top, and say we should be able to do .NET install. Control Alt. Or Control Shift A, I keep hitting the wrong thing. Okay. .NET install. Oh, I think it detected that version we downloaded. Let's try that. So it says it succeeded down here. So let's go back here. Let's hope for the best. Okay, I'm going to save that. Okay, I think it works. So a couple notes about these scripts. C# is a very common programming language for upper level stuff. You might have heard of C++ and C#. And C is closer to assembly or machine language, meaning that it is kind of like the caveman base code, sort of like hardware type stuff that is closer to like memory addresses and whatever. That might sound confusing. Basically, it's I don't want to say simple. It's not written like English language. It's easy for us to read. It's closer to computer code. So it's a little bit harder to understand for the average person. C++ built upon that, and it's got more features and stuff. It looks a little bit more like what humans are used to writing, more like the English language. And then this type of stuff, C# is one of the newer ones that is a lot more like what humans used to reading. So you can do some pretty cool stuff with it. Oh, I'm still seeing this down here. Let me check on that. I'm going to clear the output. We'll see if that comes back. I'm going to right click it. Well, we'll see what happens. So this is C# script, C as for C#. C# is compiled. And what that means, like when we do a Python script, for instance, we can run it right here as many times as we want on any computer that has the appropriate stuff. But compiled script needs to be broken down into machine code or assembly language and then made into a .exe file. So every time that you use the code or change something, you have to recompile it to .exe. So that's a little easier when you're using something like VS Code. Like I could run it. We're not going to see that whole process where it makes .exe. It's just going to try and run it here. But in the real world, it eventually gets compiled to a .exe file, an executable, like what you open your computer. Now, these always start out with importing certain functions. So there's a bunch of libraries of code out there. And since we don't need all of them for every project, they're not automatically included. Because one thing I thought to myself, I'm like, well, hey, if you got all this extra functionality, why not put it all in here? Because it's annoying or confusing if I go to use something and it doesn't work and I think I made an error, but instead it's because I didn't import it. But the truth of the matter is, if you were to put every single function that you probably won't use into every single script, they'll get bloated, large, take up extra file size, and they don't run well. So we make a policy to only bring in and use the outside libraries that we need. So using Unity Engine is saying it's using components from an external library in the script for Unity Engine. And there's some other ones that we commonly add. So let's see, I am compiling for all of you little script. Let me see if I can find it here. Let's go to docs. So I was starting a document with some basic script here, but you can see some other ones we might want to use. So I'm going to do Control C, or you could type them. Now, one super helpful thing here is you're going to notice there is what we call code coloring. So this code coloring here automatically senses what each part of this is, and it is going to code color to help us make sense of it. And this is really handy when you start programming. So make sure to save often, Control S. Now keep in mind, I did turn on autosave. That's helpful. Some of you might have noticed in class, since we have our power bricks on the floor, our surge protectors, people often kick the power button on those backs and turn off everyone's computers. And you do not want to lose your work. So make sure to turn on autosave, but also make a habit of hitting Control S frequently. Okay, so what these ones do, system collections, like when something expires, like let's say you're playing Contra and a bunch of enemies are on the screen. Now, every time you shoot an enemy and it disappears or you kill it, what if it was not cleared from the memory of your computer? Like what if it just stayed living in the RAM and on the CPU? And as you killed more and more enemies, they would just clutter up your whole system until it slowed to a drag, right? System collections helps us catch things that were used and clear them from memory. Is what we call garbage collection. So there's different functions in here, functionalities that can help us. And then also Unity Game Engine, since we're using components from that, it brings it in here. Now you're going to notice some pretty cool things you can do with Unity. Like when we grab a character, all the stuff in the inspector here actually ties directly to things in the script, right? So it's like you'll make handles here. Like let's say you make a run speed here. You can actually have that reflect in the script. So when you go over here, you can access it through code. And that's kind of the crux. This helps with that. Now, a lot of upper level programming languages like Java and stuff, they always have one big public class that most of this other stuff goes into. And when it comes to scripting, you will notice that a lot of things will declare something and then have all the code associated with it in between some braces. So what this is saying is everything between this opening curly brace and this closing one is going to be one big player controls class. And our whole script is going to run inside this thing, right? So these are external to that because they're bringing libraries, but everything we're actually coding for this process here is going to happen in between these. And if you accidentally delete one of these, if you just have an opening one and not a closing one, bad things happen. So some habits I want you to make for coding. Pay very close attention to capitalization. It really, really matters in most of these programming languages. So this is lowercase, these ones, because they are names. The way this tends to work is you have a class out there somewhere, the system's class, and you're actually using part of it. So that's why those tend to be capitalized. But this is lowercase, this is lowercase. You're going to see a lot of things like, let's see, I don't think I have any in here yet. You're going to see a lot of things where the first word is lowercase and then the beginning of every word after that in the name is uppercase. That is something called camel case. And so it would look something like this, like lowercase, capital, right? So camel case, lowercase, first word capital. You don't want to get in the habit of using spaces or a bunch of special characters in most of these things that are like names for a function. So we use camel case for things like Python, C#, etc. It's a convention, meaning it's sort of a best practices, and it's just kind of what people do. It's sort of like a habit. It won't necessarily break your code if you don't, but go ahead and follow the convention. It was set for a reason. Now, I can't really give you a whole programming class right now, so you're just going to have to trust me on some of these things. Some things called functions, they are called, right? So when you call their name by writing it with the parentheses, it will run whatever is in between the curly braces. So this is sort of like a name for whatever's in the curly braces. And so when the game starts, it's going to call this function. And when it calls start, it's going to run everything in between this curly brace and this curly brace. And then the same for update. Now here's how this sort of works with VS Code. Whatever is called at start happens once when the game starts. And whatever is called an update is going to happen with every cycle of the CPU. So CPU cycle or run the instructions a whole bunch of times in a second. So if you see 60 frames per second, because we're all used to hearing that from gaming, like 60 FPS, frames per second is usually tied into the cycles per second. So basically, if you think about that, 60 times per second is going to run these instructions. Now, you want to be thinking about how we differentiate these. Like at void start, you might want to set your player health to 100. But do you want your player's health to be set to 100 60 times per second? No, because if they get hit by a bullet and their health goes down, it will just immediately pop back up to 100. So if you put player health at 100 here, it will start at 100, but this won't be called again. It won't set it back to 100. But down here, update, you can have something that checks the health constantly, 60 times per second. And when I say 60, that's a loose figure. It's not always 60. It depends on your processor and stuff. Later, we'll use something called delta time. And what delta time does is it balances out update. So delta time makes like a time for everyone, whether they're running a slower, older computer or have a worse connection or something. They might not be cycling as many times per second. So it gives everyone the same cycle refresh that's set up to kind of like a flat variable instead of what the system can do. That way time is equal for everyone. So when you see that later, delta time, time.delta time, that is why. Okay, so things that initially start here when the game starts, things that we instantiate. And instantiate is making an instance of something. You're going to see that a lot. That's going to happen up here. And then an update, we're going to have things that are constantly being checked. So physics, where it's constantly checking for collision detection. That's going to happen in updates. If you get shot by someone, we'd have something in here that says, like, if bullet hits character, then take away 10 HP. And it would save it to a variable in here that is constantly updating. We don't want to override it with 100, like up here. What it's going to do is keep saving over top of that value. So as you lose or gain health, it is saving over top of the previous value. So things like that. Okay, so that's kind of the basis. Now, we might go in and do something like, here, let me edit the sheet here, because all this stuff should be tabs. We use tabs. Now, in Python programming language, tabs are really important. It actually changes how the code runs. But here, we're doing it for the sake of visual clarity, like how things look, right? So I'm going to say public character 2D controller. So that makes a controller class. We're setting up a variable called float run speed. So let's go ahead and try some of this here. So in player movement, I'm going to go ahead and do something that will happen at start. Now I'm going to hit the Windows key and left. What that does is it puts us to the left side of the screen. I can choose this for the right. Okay. So I'm going to take some of my code here, copy it, and I will put it into start. Now, if I right click and say format document, it's going to try and adjust that stuff to where it goes. And I can manually do it too. I'll hit tab. So what I want between this and this, all that stuff's going to run at start. The other way you can format is if you right click, notice Control Alt L will also do it. Okay. Control S to save. So we've saved that. Let's go back and see if anything is looking different to us. Notice that did a quick update when I came back here. See, the stuff is now reflected in here in the code. Okay, so that is set. We have an input system here. Okay. So let's go ahead and maybe make a little character. Let's see what all I have in here already. Backgrounds. Okay. So we've got run animation here. Okay, so we're going to create up here 2D. I'm trying to decide. Let's see. You can start with these basic ones. I'm just showing you some of the things we can start with here. You could start with an empty. There's several different ways to work around this part too. Let's make we can do a square for now. Just notice he's popped up here in my game objects. Okay. So we can add scripts to him. Now this is adding a component to this object. So we can add physics, navigation, layout effects, animations. So let's see. Let's do run speed. So I have that right there. I notice I use the camel case too. Okay, so now that we've got our player here, actually, you know what? I should probably name this player. It's a good convention, just out of habit. And the name does matter because we use that to attach certain things to it. So player with capital. Okay, so we can actually take our scripts. Maybe we'll drag that over here and attach that script to it. I'm actually going to get rid of this because we'll bring these in a different way. Remove components. Okay. So I got my script for player controls here. Okay. And let's see what we have in there. Now, a couple of things here for the player. We'll be transforming things like these transforms for the player. Once again, he's just a square for now. We'll replace them with the sprite later. And then we can do stuff like we can flip, and you can't really tell here, but it's flipping him horizontally. So you can use that when you're quickly turning and stuff, or if you went upside down, you could use that one there. And we can access those from the script. Mass we'll talk about later. Materials. You can put different sort of materials on him, like we could put that on the character. And we don't have a camera or anything on here. No, it doesn't want me to do that, so let's Control Z. Okay. Well, let's leave it on default for now. Sorting in layers, you can actually sort different elements on the Z-index, and Z-index is coming towards or away from you into the screen. Think about like depth if you're looking into the screen. So you can do some pretty cool stuff with that. We'll talk about later. Region layer mask. Okay. So we've got our script in there now. Okay. And then what we'll be doing is we'll slowly be attaching these to that player. So things like this public float will become a variable we can change with keyboard input for how fast he's running. It starts at F. Now, public means it's accessible from different functions, and that are these little, because we can make functions sort of like this, where the code inside these can only be accessed when you're inside the function. So public means it can be accessed from anywhere. Private means that's inside one of these little functions. They can't be accessed from anywhere outside those curly braces. So we're saying this public float, and float is a decimal number. The F means float as in its decimal. Integers or whole numbers would be like 1, 2, 3, 4, 5. But this would be like 40.00, etc. So we're sending the name of run speed, and this is actually a place in memory for those who are computery. But basically, think of this name as now 40.00 float, right? Float horizontal move is 0. And then Boolean means true or false. So what we're going to be using this for later, one issue you have when you first set up a character controller is that until you put in some constraints, when you hit spacebar, you tend to jump. And when you just have that attached to the input, like every time you hit spacebar, or if spacebar, then jump. Well, if you keep hitting spacebar, you keep jumping, even if you're already in midair. So you jump once, and while you're in there, you hit jump or spacebar again, and it will jump and it will keep jumping. So what we need to do down the road is set a Boolean where if we're not currently jumping, aka if jump is equal to false, and you hit the spacebar, then you can jump. That means that if you're already jumping, you can't jump a second time. And then if you're doing something like actually putting a second jump, you could make another function here that turns that off and lets you jump if you're already jumping. Or you make a count. Like if jump count is 1 or less, then you can jump. Meaning if you jump 0 times or once, then you can jump. Meaning just up to a double jump, but nothing after that. So all that stuff can be handled in the code.